Hello, everyone. So today we shall be diving into questions and answers on electrical measurement. All right, let's dive into this. Example 1 says, calculate the resistivity of a wire of length 2 meters and cross-sectional area 0.004 centimeters square if its resistance is 3.0 ohms. Alright, as a usual practice, we shall be writing out our parameters. So let's take the question again, parameter by parameters. Calculate the resistivity of a wire. So resistivity of the wire is what we are looking for, and resistivity is represented with a symbol called rho. So it's the unknown whose length is 2 meters. We are given the length of that wire to be 2 meters, and the cross-sectional area of this wire is 0.0 centimeters square. So the area here is 0.004 centimeters square. But then we need to convert our area to SI unit, which is meter square. Now converting 0.004 centimeters square to meter square would be dividing this by 10,000, and when we do that, we'll have 0.000004 meters square, or in standard form, you could also say 4 times 10 raised to the power minus 7 meters square. All right. Now we are also given the resistance of the wire, which is capital R, to be 3 ohms. The symbol for ohms is this omega here, so 3 ohms. So we have to determine the resistivity. So by formula, resistivity is product of resistance and area all over the length of the wire. So resistance of the wire is given to be 3. So we have 3 multiplied by the area, which we have converted to meter square, and this is the value. So 2 here over the length of the wire, which is 2 divided by 2. So when you simplify this, okay, with your calculator, we'll be having the resistivity of the wire to be 0.000006 ohm meter. The unit of resistivity is ohm meter. Today is it. Or in standard form, you can also say the 6 times 10 to the power minus 7 ohm meters. Anyway, it's correct. Alright, let's take another example. Example 2 says, a constant ton wire has a cross-sectional area of 4 times 10 to the power minus 8 meters squared and a resistivity of 1.1 times 10 to the power minus 6 ohm meter. If a resistor of resistance 11 ohms is to be made from this wire, calculate the length of the wire required. So writing out our parameters again, the consistent wire here has an area which is 4 times 10. So we are given the area here 4 times 10 to the power minus 8 meter squared. And it has a resistivity of 1.1. So the symbol of resistivity is rho. So the resistivity here is 1.1 times 10 to the power minus 6 ohm meter. And it has a resistance, it has a resistor connected to it, and that resistor has a resistance of 11 ohms. So the resistance of the resistor is 11 ohms, which is R here. So we have to calculate the length of that wire, that the L, the unknown. So by formula, the length can be calculated with this formula. Length of the wire will be RA over resistivity, where our R is the resistance. So R is 11 multiplied by the area, which is 4 times 10 to the power minus 8, all over resistivity, which is 1.1 times 10 to the power minus 6. So we've substituted all our values of the variables. And when you simplify these, your result will be 0.4 meters as the length of the wire. Alright, let's take another example. It says, a wire of length 100 centimeters and cross-sectional area 2.0 times 10 to the power minus 3 centimeters squared has a resistance of 0.10 ohms. Calculate its electrical conductivity. Alright, We use this symbol to represent electrical conductivity. That's what we are looking for. So this symbol here represents conductivity, and is the unknown. We have a length of the wire to be 100 centimeter. That's our L is 100 centimeter, but we need to convert it to meters. So 100 centimeter is 1 meter. So L is 1 meter. Okay, in meters. Also, we are given the area to be 2.0 times 10 to the power minus 3. So that's a 2.0 times 10 to the power minus 3 centimeter square. But we need to convert it to meter square. And doing that, all you need to do is to divide by 10,000. And when you do that, we will having our area to be 2.0 times 10 to the power minus 7 meter square. Again, we are given the resistance, which is R, to be 0.10 ohms. So all we need to find the conductivity. Conductivity is just the reciprocal of resistivity. So conductivity is equal to L over RA. Resistivity is the reverse case, but that will be RA over L. But now in this case, we are looking for conductivity. That will be L over RA, where our L is now 1 meter. Okay, there is it here, value of our L. So we substitute the value, which is 1 over R. Our R already is 0.010, so we substitute it here to be 0.10 rather. So we have 0.10 multiplied by our area, which have been converted to meter square also. That is 2.0 times 10 to the power minus 7. That's it here, 2.0 times 10 to the power minus 7. When you simplify all of this, we have our conductivity to be 5 times 10 to the power 7 per ohm per meter. So this is a unit for conductivity. Remember, if it is resistivity to be ohm meter, but because the reverse of resistivity to be per ohm per meter. All right, so that is the conductivity of the wire. Okay, another example, it says a 2-meter wire of resistivity 5.5 times 10 to the power minus 7 ohm meter has a cross-sectional area of 0.50 millimeter square. Calculate its resistance. Okay, again, we write our parameters. Okay, we are given the length of the wire to be 2 meters here, so we have L to be 2 meters. Resistivity is given to be this value. So resistivity by symbol is rho. So rho is 5.5 times 10 to the power minus 7 ohm meters. And then we are given the cross-sectional area, that's our capital A, which is 0.50 millimeter square. But our area must only be in meter square. So converting 0.50 millimeter square to meter square, all you need to do is to simply divide by, divide it by 1 million. So when you divide it by 1 million, we have our area to be 5 times 10 to the power minus 7 meter square. Now to calculate the resistance, that's the unknown. Now to calculate the resistance by this formula, resistance will be resistivity times length over area. Okay, resistivity is given already to be this, so we substitute the value 5.5 times 10 to the power minus 7 times the length, which is 2 meters, all over the area, which have been converted to meter square. That's 5 times 10 to the power minus 7. When you simplify all of this, we have our resistance to be 2.2 ohms. Okay, so let's take the last question for today and we'll wrap it up. Here it says a wire of length 15 meters made of a material of resistivity 1.8 times 10 to the power minus 6 ohm meters has a resistance of 0.27 ohms. All right, so he said determine the area of the wire. Okay, so in our usual way, we write our parameters. The length is given, which is 15 meters. Resistivity is given, that is our rho at 1.8 times 10 to the power minus 6 ohm meters. We are given resistance as well to be 0.27 ohm, and we have to find the area. So by formula, area is resistivity times length over resistance. Resistivity is 1.8 times 10 to the power minus 6. The length is 15, and the the resistance is 0.27. So when we simplify all of these, the value will give us 0.0001 meter squared. Yes, so this is where we shall be doing the cutting for today. Thank you for listening. Bye for now.